Hello wonderful people, it's Medicosis Perfectionatus. Welcome back to my physics playlist. In previous videos we talked about measuring units, introduction to physics, scalar quantities versus vector quantities. As for today, let's compare between distance and displacement. Distance is a scalar, displacement is a vector. What do I mean by distance is a scalar? It means it's an entity that has a magnitude only, but no direction. As for displacement, the vector, it has both a magnitude and a direction. From distance, the scalar, we can derive speed, the scalar. And from displacement, the vector, we can derive velocity, the vector. What is the difference between total distance and net displacement? Let's figure this out today. As always, there are tons of practice problems today, so grab a sheet of paper and let's see how many questions you'll answer correctly. Please click the like button, click the subscribe button, and let's get started. This is video number 5 in my physics playlist. Please try to watch these videos in order. And if you need help with any other topic beside physics, please check my other playlists. Let's go. Scalars versus vectors. Scalars have a magnitude only, but no direction. Vectors do have both a magnitude and a direction. Example of scalars include distance, speed, pressure, mass, energy, time, temperature, work, area, volume. But look at this. Distance is a scalar, but displacement is a vector. Speed is a scalar, but velocity is a vector. Mass is a scalar, but weight is a vector. Work is scalar. The ability to do work is scalar. However, torque is a vector. If you wish to see more physics videos in the future, please drop a car emoji in the comments. Let's try this one. Adam walked from 0 to 2 on the number line, then from 2 to 4, positive 2 to positive 4 to be specific. What is the total distance and what is the net displacement? Please pause and try to answer this yourself. Okay, distance, you just add all of them up. So first I walked from 0 to 2 like this, and then from 2 to 4 like this. From 0 to 2, you have 2 meters. Here is 1, here is 2. And from 2 to 4, here is 1, here is 2. So you have 2 meters here plus 2 meters there. So distance, or the total distance, equals d1 plus d2, which equals 2 meters plus 2 meters, which gives me 4 meters in total. That's the total distance. But what is the net displacement? Net displacement is different. For net displacement, let's call that delta x equals the final position minus the initial position. What's my final position? It was 4. And what's the initial position? It was 0. So 4 minus 0 equals 4. And this has to have a direction because displacement is a vector. So you can say positive 4 meters, that is correct. Or you can say 4 meters to the right, which is also correct. Or you can say 4 meters east. Here is another example for you. If I started at this point, let's call it point A, and then I walked to point B like this. Then I walked back from B to A. And let's suppose that from A to B is 3 meters and from B to A is also 3 meters. Please calculate the total distance and the net displacement. First, total distance equals d1 plus d2 equals 3 meters plus 3 meters, total 6 meters, that's the total distance, period. Next, how about the net displacement? Well, I left point A and then eventually I came back to A. So the final point is A. The initial point is also A. Final minus initial is nothing. So the net displacement is 0. I was not displaced because I started at A and I returned at A. So at the end of the day, I was not displaced, so to speak. Let's try this one. Mr. Adam walked from negative 3 to positive 2, then from positive 2 to negative 1. What's the total distance and what's the net displacement? Please pause. Let's do it. Where is my first distance? It's from negative 3 to positive 2, like this. How many meters are there? 1, 2, 3, 4, and 5. So this is 5 meters, and we can call this D1. Then I walked from positive 2 to negative 1, like this. How many meters are here? Here is 1, here is 2, and here is 3. So we can say that D2 is 3 meters. What is the total distance? D1 plus D2 equals 5 meters plus 3 meters. Total is 8 meters. This 8 meters is the total distance that this doofus walked. Next, what's the net displacement? For the net displacement, delta x, it is the final position minus the initial position. What's the final position, please? It is -1. And what is the initial position, please? Careful, -3. So you need to open parentheses or brackets like this. So this is -1 plus 3, which equals +2 meters, meaning Adam was displaced 2 meters east. Let's see. Here's the initial position, okay? And here is the final position. Oh, what's the difference? Displacement of 2 meters east. And that's the net displacement equals +2 meters. Notice the distance is a magnitude only, but displacement has a magnitude and a direction. If it has a positive sign, it means that Adam was displaced to the right. But if it has a negative sign, it means that Adam was displaced to the left. Question number 3. What's up with this dude? Adam again walked 3 kilometers east, then 4 kilometers north. Please calculate the total distance and the net displacement. Pause and try to answer this yourself. So how do we do it? So Adam walked 3 kilometers east like this, and then after this, 4 kilometers north. What is the distance? Total distance equals distance 1 plus distance 2, which equals, so d1 plus d2. d1 is 3 kilometers and d2 is 4 kilometers. 3 plus 4 equals 7 kilometers, and this is a scalar quantity, which means only a magnitude, no directions, so 7 kilometer is the total distance. How about the net displacement? Look, Adam started here and ended there. This right here is the displacement. How do you do it? You call it the tail to tip method. From the beginning of the first one, that's the tail, until the end of the last one, and that's the tip. Tail to tip method. This will be the displacement. How can I find this? Since this beautiful thing is a right angle triangle, I can use Pythagoras theorem, which means this displacement squared equals 3 squared plus 4 squared. This 3 and this 4, which will give me 9 plus 16, and this is the x squared. How about x alone? You need the square root of 9 plus 16, which is 25. So x equals 5 kilometers in this direction, 5 kilometers northeast. Since this is displacement, you have to say the direction, northeast. Not to be confused with norepinephrine. Here's the same answer in color. The total distance is d1 plus d2. You keep adding all the distances together, just the magnitude only. 3 plus 4 is 7 kilometers, period. That's it. As for the net displacement, from here to there, because I started here and ended there. So how do I get this? Pythagoras. And you'll get 5 kilometers northeast. Remember when I told you in the last video that you need to memorize the famous Pythagorean triples, such as 3 and 4, what's the third one? 5. Or 5 and 12 and 13. Or 8 and 15 and 17. Now let's answer the questions of the previous video. If F in the x direction horizontal is -50 Newton and the force in the y direction is 120 Newtons, please calculate F. Pause and try to answer this yourself. So in the x direction, I'm -50, so I have to go left like this. This is -50 Newtons, and this is Fx. Then I need F in the y direction, which is 120, positive that is, which means upstairs, and this is Fy. Now, what is F? They are asking about this. This is F. How can I find this? It's good old clean Pythagoras again. So if I want this F, I need the square root of 120 squared plus 50 squared. And when you do this, remember, it is 12, 5, and 13. So it's going to be 130 Newtons, and this is the value of F. But remember, force is a vector. So I need a magnitude and a direction. This direction is up and to the left. You can say northwest. Here's the same answer in color, -50. You have to go to the left side on the x-axis, and then the Fy is positive 120, so you go up, which means the net force is here in the second quadrant. Use Pythagoras to find F. Easy peasy, don't forget the magnitude and the direction. So if I need f, I use Pythagoras like this. But what if I need fx? If you need fx, you need f cosine theta. Why is this? Because cosine theta, remember cosine is the adjacent over the hypotenuse. Where's the adjacent of theta? This is fx. Where is the hypotenuse? And this is just f, okay? So this is correct, which means you can do cross multiplication, or you can multiply each side by f to get this. Fx equals f cosine theta. But how about if I want fy? We use sine for this. Remember that sine theta is opposite over hypotenuse. What is the opposite? That's fy. What's the hypotenuse? That's f. Cross multiplication, or by multiplying each side by f, you get this. So fy equals f sine theta. So fx is f cosine theta, but fy is f sine theta. How do I remember which is which? This has a q sound, fx, and this is cosine. But fy has the I, sine theta. Okay, so if I need f, I use this equation. If I need fx, I use this. If I need fy, I use this. But what if I need the theta angle itself? Well, since tan is always rise over run, fy over fx, therefore the inverse of tan, or the cotangent, is fx over fy. It's just the opposite. If you want theta alone, you bring this inverse tan to the opposite side, and you have to reverse this, so this is how you get theta. You can download these colorful notes at medicosisperfectionalis.com. I help you learn, understand, and pass exams. More practice. Question 5. A force of 10 newtons was exerted at an angle of 30 degrees. Split the vector into its two components, please. And here are some hints for you. So let me draw my quadrants like this. Okie dokie. And where is F? 10 newtons at 30 degrees. So let me draw this like this. Here is F, and it equals 10 newtons making 30 degrees with the x-axis, or the positive x-axis to be specific. Nice. Now, if you want fx, it is f cosine theta, okay? What is the f? It is 10 newtons. And what is cosine 30? Cosine 30 is square root 3 over 2. You can cancel 2 with 10, so this becomes 1 and this becomes 5. So the answer is 5 square root 3 newtons. Where is that here? This is the x component. So this that you see right here is the x component. So fx equals 5 square root 3 newtons. In which direction? This is east. This is a positive sign. Next, how about finding the y component, which is here? To find the y, we use the f sine theta, okay? How much is the f? The f is 10 newtons. And what is sine 30? Sine 30 is half, like this, and this will equal 5 newtons. So Fy equals 5 Newton, and this is a positive sign because we're going north. And here is the same answer in color. Please take a moment to pause and review. This is the triangle that we created. It's a right angle triangle. The x component here is 5 square root 3 newtons, positive. And the y component here will be 5 newtons going north. So that the total force is 10 newtons going northeast, making 30 degrees with the horizontal. How about this one? Find the components of this vector. We have a force of 100 newtons at 30 degrees above the x-axis. Please pause. So let's draw this. Okie dokie. Here is F, which equals 100 newtons in this direction, making a 30-degree angle with the horizontal. Amazing. So we need a horizontal component, which will be called Fx, and we need a vertical component, which we'll call Fy. Can we find these? Easy. Remember, Fx equals F, it is x, so cosine 30. How much is the F? The F is 100 newtons, and how much is cosine 30? It is square root 3 over 2. You can cancel 2 with the 100, becomes 50. So the Fx is 50 square root 3 newtons going east in the positive direction. And let's write this down here. Nice. Let me get the Fy then. If you want Fy, Fyi, look at this, Fyi. So I need the sine theta. Look at this I. Okay, what is the F? It is 100 newtons. And what is sine 30, please? Sine 30 equals 1/2. 1/2 of 100 is 50 newtons, and this is a positive amount going north as you see. Here's the same answer in color. Sometimes you can write this down in one line. You have the x component, so you write that first. Then you have the y component, you write that last. And just like x comes before y, I comes before j. Ta-da! Those freaking mathematicians are so creative. And then they make fun of doctors for naming diabetes type 1 and diabetes type 2. Well, look at you. Look in the mirror, buddy. You did that too. Question 7. Let's go. Find the components of this vector, a force of 200 newtons at 210 degrees below the x-axis. Please pause and try to answer this yourself. Okay, you gotta be very careful with this one. Okay. Notice they said 210 degrees below the x-axis. Where's the x-axis? This is your x-axis. Below it, so you start counting this way. This is 90 degrees, okay? So if I go from here to here, that's just 90, but I need 210. So how about another 90? That will take me up to 180, but I still need 30. Oh, like this, 30 degrees here. Oh, nice. So the direction of the force, may the force be with you, is here. How about the angle here? Will be 60, so that 30 plus 60 is 90. And how about the angle here? This is 90. 60 plus 90 is how much? It is 150, baby. Okay, so I have two methods of describing the angle. I can say 150 degrees above the x-axis, or I can say 210 degrees below the x-axis, which means there are two ways of solving this. The easiest one is to look at the 150 above the x-axis. Okay, so this is the angle that I'm playing with. Give me that f in the x direction, okay? In the x, it's gonna be cosine theta, okay? How much is the force? 200 newtons. And cosine what? Cosine 150 degrees. And how much is cosine 150 degrees? It is negative square root 3 over 2. Okay, so this 2 can become 1 and this 200 can become 100. So I end up with negative 100 square root 3 newtons. Why is this a negative sign? Because look at the x component. It's in the negative x direction. Not positive, not this way, but this way. So this is fx equals negative 100 square root 3 newtons, and this is the x component. Now, what is missing is to find the y component, this doofus right here. How do I find the y component? Fyi. So it is f sine theta with a big I in it. So how much is the f? 200 newtons. And how much is sine 150, please? It's just like sine 30. It is half. So 200 times half is 100 newtons. Is this a positive sign or a negative sign? It's a positive sign. Why is this? Because look at me. I'm going up in the positive direction on the y-axis. I'm not going down. That will be negative. I'm going up, baby. And this is a positive direction, making Fy equals 100 newtons going north in the positive direction. If this is a distance and this is a distance, this will be the net displacement. By the way, there is another way to answer this. You can just look at this triangle. I have an angle of 30 degrees. I have an F here, which is 200 newtons. Then I'm trying to find Fx and Fy. You can use the same shebang, but instead of 150 degrees, you can use 30 degrees, but you gotta be very careful. After you get the answers, you have to make this a negative sign and this a positive sign. That's why I prefer to use 150 degrees, which is above the x-axis. Always count the angle from the positive x direction like this, so that the answer already has the correct sign for you, so that you do not have to think on your exam. Because let's face it, you do not have enough time. If it's 210 degrees below the x-axis like this, it's as if we're saying it's 150 degrees above the x-axis. It is better to use 150 degrees as your theta instead of 30, because the 150 degrees will give you the correct sign every time. And then you can represent both of them using this IJ formula. Back to good old distance and displacement. An object moves across the circumference of this beautiful circle from point X to point Y. Please note that the radius of this circle is 7 meters. Find the distance and the net displacement. Please pause. Okay, what is the distance? Well, I'm walking. All of this is the distance, okay? So from here to here is the distance. Oh, okay. This is, suspiciously enough, half of the circumference of the circle. Nice. So the distance equals half the circumference of the circle. What is the circumference of any circle? 2 pi r. Pi is the pi, 3.14. What is the r? That's the radius. Which means distance equals half times 2 pi r is 7 meters, as you know. You can cancel the half with the 2, so the end result is pi times 7. Pi is 3.14 or 3.14159 for those of you who are squeamish. So about 3 times 7 will give me something around 21, right? Yeah, that's close enough. Okay, that's the distance, but how about the displacement? Well, I started here, I ended there. What is displacement? Final point minus initial point. Oh, just straight away across it. Oh, suspiciously enough, the displacement is the diameter of the circle. Displacement equals diameter. Diameter equals twice the radius. How much is the radius? 7 meters. 2 times 7 is 14 meters is the net displacement. So 14 meters is the correct net displacement. But a better answer is positive 14 meters because you're going to the right, because displacement is a vector. And here's the same answer in color. Pause and review. And again, it's better to write down positive 14 to show me that you are respected in your community. Next, a woman walked 40 meters east, then traveled 50 meters north, followed by 80 meters east. Please calculate the total distance and the net displacement. Pause and try to answer this yourself. So she walked 40 meters east. Amazing. And then after this, 50 meters north. Okie dokie, like that. After this, she traveled 80 meters east. That's a good woman right there. Because God loves those who walk in zigzag lines. I don't know what the flip I'm saying. 40 meters, then 50 meters, then 80 meters. What's the total distance? Easy. The total distance is always the sum of all of the distances that you have. It is always d1 plus d2 plus d3, which equals 40 meters plus 50 meters plus 80 meters. So the total distance is 170 meters. That's my total distance. That's the answer for that. How about the net displacement? Oh, I started here, I ended there. Remember that net displacement is the final point minus the initial point, or the tail to tip method. So what I'm trying to find, this is the displacement that I'm trying to find. Oh, all of this line? Yes, indeed. How can I find this? Oh, it seems impossible, unless you can rearrange the triangle. If the distance from here to here is 50 meters, then the distance from here to here is what? The same 50 meters. Okay, so I can get that 80 meters here. Nice. It's the same distance as the 80 meters up here. And the 50 meters will be there. Okie dokie. Nice. And then you can just ignore this 80 meters and this 50 meters. So let me erase them. Voila, nice editing. So now I have a triangle. It is a right angled triangle as you see here. So what are my sides? I have 50 here and 40 plus 80 or 120 here. Just like this. And I can find the net displacement via Pythagoras. The net displacement, let's call it x, equals the square root of 120 squared plus 50 squared. And if you have memorized my Pythagoras triples, it is 5 and 12 and 13. X will be 130 meters. And since this is displacement and displacement is a vector, you have to write the direction. This is northeast. And here is the same answer in color. She walked this way, and this way. So the total distance is 40 plus 50 plus 80, which is 170. If you want the displacement, you want this line. Just rearrange your triangle like this, and you will get the answer as 130 meters. And here are the Pythagorean triples that I'm talking about. 3, 4, and 5. 5, 12, and 13. Or you can make this 30, 40, 50. Or 50, 120, and 130, just like the triangle that we have practiced. Please take a moment to pause and try to memorize at least this column of Pythagorean triples. It's going to save you a lot of time on your exam. How about this? Sarah, finally, not Adam, walked 120 meters east, then traveled 150 meters south, and then 40 meters west. What is the total distance and the net displacement? Please pause. So 120 meters east like this, followed by 150 meters south like this. And then we have 40 meters west like this. Nice. Then what? I want the total distance and the net displacement. Total distance is easy. It is d1 plus d2 plus d3. 120 meters plus 150 meters plus 40 meters for a total of 310 meters, and this is my total distance. How about the next part of the question? Net displacement. Where did I start? I started here. Where did I end? I ended here. So tail to tip method. Let's draw the line. This is the displacement that I want, but how can I find this? It seems impossible until we rearrange the triangle. If this side is 150 meters, then this will be how much? Also 150 meters. Okay, but how about this part right here? Well, let's think about it. If this is 120 and this piece is 40, then this is how much? Oh, 120 minus 40 is 80 meters. Okay, like this. Now this is my new triangle of concern. I have a right-angled triangle here. One side is 150, the other is 80, and then the unknown is the hypotenuse. Let me erase everything else. And just like magic, you have a new triangle. We're trying to find the displacement, or x, Pythagoras baby. It is the square root of 80 squared plus 150 squared. Or if you have memorized my Pythagorean triples, remember 8, 15, and 17, or 80, 150, 170. X equals 170 meters, and this is the net displacement. But I'm not done yet. I need to write down the direction. Let's review the directions. Okay, just take a moment to write them down. But I know them! In the heat of the moment during the exam, you might mix them up. So where is x going? X is going this way, so it is southeast. And let's write this down here. So 170 meters southeast is my final answer for the net displacement. Distance is a scalar, but displacement is a vector. Here is the same answer in color. How about this question, number 11? This graph represents the relationship between displacement in meters on the y-axis and time in seconds on the x-axis. Please find the total distance traveled, next the net displacement, and third, the slope of this green line, and tell me what does that slope represent. This is your homework for today. You'll find the answer key to these questions in the next video titled Speed versus Velocity. At the end of each video, what do? Equations time. So let's go. What is the total distance? Equals d1 plus d2 plus d3, etc. Okay, how about net displacement? This is the final point minus the initial point. Distance is scalar, displacement is a vector. And speaking of vectors, let's draw like this. Here is the theta. Let's call this f, this fx, and this is fy. How do I find f? Pythagoras, square root of fx squared plus fy squared. How do I find fx? X equals cosine, so it is f cosine theta. How do I find fy? Fyi, this is sine theta. And how do I find theta itself? It is the cotangent or the inverse tangent of, be careful, y before x. Please don't just look at the screen, but get a piece of paper and write down these equations. From memory, do not cheat. Distance is a scalar, but displacement is a vector. Distance has a magnitude only, but no direction. Displacement has both a magnitude and a direction. From distance, speed is derived, and from displacement, velocity is derived. Distance over time equals speed. Displacement over time equals velocity. Scalar divided by scalar will give you a scalar, but a vector divided by a scalar will give you a vector. Who else is gonna teach you like this? Your professor with his PowerPoint? Give me a break. You can download these wonderful, colorful notes at medicosisperfectionalis.com. I help you learn, understand, and pass exams. On my website, I have general chemistry notes, organic chemistry notes, biochemistry notes, physiology notes, biology notes, anatomy notes, all kinds of notes. Just go to medicosisperfectionalis.com. This YouTube channel is not just for physics. I have physics, biology, general chemistry, organic chemistry, biochemistry, anatomy, physiology, embryology, pathology, internal medicine, surgery, obstetrics, gynecology, all kinds of stuff. If you want to learn how your kidney functions, the glomerular filtration rate or GFR, what happens precisely in the proximal tubule, loop of Henle, distal tubule, collecting ducts, etc., download my kidney physiology course at medicosisperfectionalis.com. There are more than 600 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine makes perfect sense.